we're gonna do regressions, right? We're modeling logarithmic patterns. So just write down regressions, right? And note that when you do logarithmic regressions, the only option that our calculator gives us is natural logs. So ln reg. And your equation should look like that. So let's do our first equation, jump right in. Because you don't have to make your own points when it comes to logs. They will give you the points. The flash on most digital cameras requires a charged capacitor in order to operate. The percent charge, Q, remaining on the capacitor was recorded at different times, T, after the flash had gone off. The T5 flash duration represents the time until a capacitor has only 50% of its initial charge. The T5 flash duration also represents the length of time that the flash is effective to ensure that the object is being photographed properly. Construct a scatter plot of the given data. So let's type this in, and without even, you never argue, the first column is always going to go into our L1. The second column always goes into L2. So that is essentially saying the first one represents our X values. The second column represents our Y values. Okay, so let's go ahead and enter that. I already did. Okay, so I beat you to it. And how do you look at the scatter plot again? You want to press, or you're still clicking away. Go ahead, click away. It's a very satisfying sound to hear you click. That means you're not on your phone. Okay. Y equals. I'm going to clear any equation that I have in there. I don't want anything in there right now. And I'm just going to ask you to, when you do a regression, it's probably a good idea to turn on plot 1. Okay. I have it turned on at this point. It's highlighted. And then I go zoom 9 right away, zoom statistics, because it's using the points in L1 and L2. And there you have it. Question, how do we know for sure that this cannot be an exponential function? Because of the x-intercept, right? This one actually lands on the x-intercept, on the x-axis, so it cannot be an exponential. Just one thing to notice. So let's do a regression here. Construct a scatter plot. Scatter plot shows a logarithmic pattern. Also, the fact that it has an x-intercept rules out an exponential. The fact that it has an x-intercept rules out an exponential. Let's determine the logarithmic model for the data. So equation, basically asking for an equation. So we're going to go stat calc ln reg, not linear regressions, please, because you're going to get it wrong. So let's go ahead and do that. stat, calculate. It's all the way, I don't like that they put them together, linear regression and LN. And I never clarified, but do you notice that there's two linear regressions? It doesn't matter which one you pick technically. I would always pick the very first one here. That's the one, if you do linear, pick the first option, not the second one. It's just a different way of writing it. But anyways, we're going to go linreg, second 1, comma, second 2, comma, alpha trace, enter. And this is our equation. Y is equal to 0.46 plus, minus, I should say, 0. Look at what's happening there. It's 998. So even if you round to 4 decimals, you'll keep the 0.0998. That's probably a good idea. But again, if you round it to 2 decimals, this would round to 0.1. Okay, this would actually round to 0.1. Regardless of which one you chose, you'll be fine. Okay, ln of x. You have to have the y and the x every single time. Okay, you will lose half a mark on the exam if you miss that. So make sure it has a y and the x. And let's hit graph to see if it actually works, and it does seem to work. Do I see the y-axis on this graph? I don't see the y-axis, so I'm going to make a few changes here. Window. Look at where it has zoomed into. My x min is 34. My x max is 105. I want the x min to be in the negative, so I'm going to go -2 and hit graph. So now I see the y-axis, right? I want to see a little bit more to the top, just so I can see it getting closer to the y-axis. So let's go to our window. Look at our y max. It's a very tiny number to begin with, right? I wouldn't increase it by a whole lot. I might go 0.5 or 0. Something that isn't extremely high of a number, but because look, that's already it. And if you think about it, my y values are very, very small. That's why if you go to your window, the y values are also very small. Like I'm not looking into the thousands or not even a whole number. Okay, so that's something to keep in mind that could happen from time to time. So just kind of try to read the situation. Okay, so we've got that. Use your logarithmic model to determine the T5 flash duration to the nearest hundredth of a second. T5, right, T.5 means that a charge of 50% remains. That's what it means, that T5 is really saying, hey, the percent of charge is 50%. And guess what? That is our x. It's basically giving us our x value. So it's basically saying if x is equal to 50, what is the t? What's the time there? So I got to go second, trace, value, x is equal to 50. Second trace value, x is equal to 50, and it's 0.07 if you round it to 2 decimals. I'm gonna go with 3 decimals, and this is seconds. And the reason being is because I see a 0.07 here in my table. So to be a bit more specific, a T5, right, is this many seconds. But regardless of how you round it, you would have received the correct marks there. And a question wouldn't be complete without domain and range. And I would strongly encourage you, if you don't have a diagram on your paper, to make one real quick, right? Where this represents the charge and this represents the time. And we have the asymptote here, never crosses. So the graph kind of gets to the point where the x-intercept is. And that x-intercept is 100, 0. Okay? So the charge is 100%. So think of a camera, like, I don't know if you remember the old cameras with an actual, yeah. So it's 100% charge, and if you press the, if you actually take a picture, the capacitor sends a charge to the flash, right? And sometimes, depending on how long that flash is, right, it will drain that capacitor. So at the very beginning, at time 0, you're at 100%. Okay. So for domain is your x values, okay, along the x-axis. You will never touch 0 per se, so you have to have a round bracket there. All the way to, does it actually touch 100? Is 100 included? Yes, it is. For the range, it's the y values. And so the lowest y value is 0, and it is included because it actually touches y equals 0, and it goes to infinity. Let's do the set notation just in case. Or this one here. I got to use x and y because they didn't give me an equation. So this one is kind of tricky. X is greater than 0, less than or equal to 100. This is the tricky part here, no equals here. Or when it comes to range, y is greater than or equal to 0. Okay, so this one is probably the trickiest one to come up with a domain and range. Okay. Okay, I'm going to stop there. Actually, I'm going to say, if you want to try one of these, it's on page 50. I don't have a whole lot of these to practice, but page 50 has a regression question. Okay. And I'm entering kind of like the review mode. So I'll ask you to try page 50 specifically for this, but I'll just say anything from page 50 to 54 is already starting to review for our upcoming assessment. So 50, I'm looking at 50 here. 54. So just practice those for tomorrow.